Study the compound light microscope in detail, not just the parts, but also the working principle, magnification, resolution, and the scientific reasoning behind oil immersion. This explanation is suitable for class 12 or BSc students and anyone who wants a deeper understanding of microscopy. The compound microscope works on the principle of refraction of light through multiple convex lenses. It uses two lens system. The objective lens, which forms a real inverted image, magnified image. The eyepiece lens, which is the second one, which further magnifies this image from a virtual image that we observe. So technically, the microscope does not magnify the specimen directly. It magnifies the image formed by the objective. Now let's compare what's magnification and resolution. It is important to understand that magnification is not everything. There are two important terms when it comes to magnification. So the total magnification is equal to the magnification of the objective and the magnification of the eyepiece. For example, a 10x eyepiece combined with a 40x objective gives us a 400x magnification. However, resolution is the ability to distinguish two closely spaced points as separate. The resolving power depends on the wavelength of light and numerical aperture of the objective. The formula for resolution is the resolution is directly proportional to lambda divided by twice the numerical aperture. Lower wavelength and higher numerical aperture gives better resolution. This is why simply increasing magnification does not always give more detail. Coming to the mechanical parts, this is the arm which supports the optical components. The base provides the mechanical stability and houses the illumination system. Mechanical stability is extremely important because even slight vibration can reduce image clarity at high magnifications. Now coming to the optical components, it's usually 10x or 15x. Mine you can see it is 10x. It magnifies the intermediate image formed by the objective and zooms it. This microscope also have diopter adjustment. As you can see, it is used for correcting vision differences between the eyes. Now this is the revolving nosepiece and these are the objective lenses. Here in my microscope I have 4 objectives. This is the 5x, this is the 10x, this is the 45x, and this is the 100x oil immersion objective. Each objective has a specific numerical aperture value. Here for 100x you can see it is 1.25 and for 45x it is 0.65. You can also see that here you can see it clearly, it is 0.25 for 10x and 0.1 for 5x. So each objective has a specific numerical aperture and the working distance. Also you can see the working distance when the magnification increases, the working distance reduces. See, with 100x the working distance is much reduced. So with 5x the distance is very high. It keeps reducing as the magnification increases. You can also see the numerical aperture increases as the magnification increases. Since the working distance reduces when magnification increases, to capture the same amount of light, the aperture needs to be increased. Now let's understand how oil immersion works. At 100x magnification, we use immersion oil. But why? Because when light passes from glass light to air, it bends due to diffraction. This causes light loss and reduces resolution. Immersion oil has almost the same refractive index as glass. So when oil is placed between the slide and objective, light does not refract significantly. More light enters the objective. Numerical aperture increases, the resolution improves. That's why oil immersion is used for observing bacteria. Now this is the stage. This is where the specimen is placed. Also it has a mechanical clamp where you can place the glass slide. This has two knobs here. One is for the x-axis movement and this is for the y-axis movement. So it helps us to accurately place the specimen at the exact position where it is needed. So this is how the focusing mechanism works. It has two knobs. One is the coarse adjustment knob and this is the fine adjustment knob. The coarse adjustment moves the stage rapidly, used only under low power. The fine adjustment moves the stage minimally, required for sharp focusing under high power. Also, the depth of the field decreases as magnification increases. So, at high magnification, only a thin layer of specimen remains in focus. This is the condenser. The condenser concentrates the light onto the specimen. The iris diaphragm regulates the amount of light. Increasing light intensity does not always improve the image clarity. Proper contrast, which can be also adjusted by moving this knob, is very important. Also, this microscope has a knob to adjust the condenser level. Like you can increase or decrease the height of the condenser. Some microscopes like mine has a light source. That you can see the switch here. So the lights gets on and this is adjustment knob where you can adjust the intensity of the light. Some microscopes have the built-in LED like mine, or some have the halogen lamps. Brightness should be adjusted based on the objective magnification. Too much light reduces the contrast. Also, after every time you use the microscope or every time you use the oil immersion, the 100x, clean the lens immediately and only use clean lens cleaning tissues and not any other clothes. So in summary, the compound light microscope is not just a magnifying device. It is an optical system based on refraction, numerical aperture, resolution, controlled illumination. And understanding this principle is essential for microbiology, histology, pathology, and research applications. Kindly let me know in the comment section which part would you like to know about in my next video. Thank you.